Okay, grade 12 college prep physics. We're moving into sort of the second part of the mechanical systems unit, and it's on machines. And we focus on what we call simple machines. So there's no high-tech machinery going on in our physics class, but this is the very basics. And there are actually little categories of machines. And yeah, that's what this unit's about. And we talk about mechanical advantage and efficiency of machines and how you can increase mechanical advantage. So first of all, you should write this down, the 5 functions of a machine, okay? Changing energy from one form to another. We haven't really talked about energy yet in the course, but if I use a windmill as an example, it would be a machine, a compound machine, they're called when they're not simple. And it would change wind energy to electrical energy, right? So you take one type and you make it another type, okay? Transfer forces. Your transmission takes the force in the motor, and it transfers it to the wheels of the car, so you can actually move forward. Changing direction of force. This is like a pulley, right? A flagpole. You pull down, and the flag goes up, and sometimes that helps with your mechanical advantage. Change the size of force, and a great example is a car jack, because you can lift the whole back end of a car. You couldn't do it with your arms, but by pushing down on a jack you can, right? And that's really what we focus on in this part of the course, or in this course I guess in general, is the idea of machines that will give us mechanical advantage. And changing distance or speed. And what I mean by that, the gears on your bike, you can change, the speed you pedal, but you won't go as far. It's sort of a trade-off, right? Okay, so you want to get that down. You might want to pause to finish writing that, but I'm going to move on with the tape or with the video. Okay, so looking at simple machines, again, we're focusing on simple machines in the course. A compound machine compared to a simple machine. A compound machine is one that has several simple machines made up in it, but a simple machine is just one basic, simple, very simple thing. And an example is a lever, right? Here's someone using, again, trying to make it easier to lift this mass here by using a lever over a fulcrum. So this would be the pivot point. That's what's called the fulcrum. The language we use with levers. The load is what you're lifting, and load is what we call a weight, right? And we know that weight is not the mass. We think of it in terms of force of gravity. The effort is the word for how much force you have to apply, or this guy has to apply on the simple machine. And arm, the word arm, and this seems kind of odd, but it's the word that often gets used that represents the distance from either the load or effort to the fulcrum. And what I mean by that, sorry, I know you're probably trying to write, but like the load arm in this case would be from where my cursor is right here, the fulcrum, to the load. And that would be called the load arm, and it'd be a distance. You'd measure, say that's 20 centimeters. Then the load arm is 20 centimeters. So if you hear the term arm, I'll come back here so you can get writing. If you hear the term arm, that's what it means. It's a distance. Okay, again, you might need to pause, but I'm just going to move on. Okay, so something I want you to sort of at some point put to memory or put on your formula sheet is the 3 classes of levers. And so let's just take a look. A first class lever I think of as a teeter-totter. Okay, you've got a fulcrum, you've got a load, and your effort's on the other side. So they straddle the fulcrum, right? The effort and the load force. A second class lever has the load in the middle and the fulcrum on one end. And we'll see lots of examples of these, but just, if you sort of start to put down this in your note, what is what, and then as we go through examples, we'll say, okay, that's a second class lever, that's a first class lever, etc. And the third class lever is if the effort's in the middle. So the things that you'll want to remember over time is in first, the fulcrum's in the middle, in a second, the load is in the middle, and in a third, the effort's in the middle. And like I say, you'll start to see more examples of that as we move on. Okay, so looking at the body, for example, I have a first class lever, a second class lever, and a third class lever. So I think you have this down in front of you. So in a first class lever, the example is lifting your chin. And let's just, not think about the other two for now. So lifting your chin. So take a picture. If you look at the picture here. And here is actually the fulcrum, right here at the base of your neck. Okay, think of yourself lifting your chin up, pulling your chin up. That's where the fulcrum is. And the effort is down here, and the load is the chin. And so here, if this is the fulcrum, it's like on either side, right? And that's why it's a first class lever. Our body, by the way, as you can tell, is obviously a compound machine. We're made up of many, many simple machines. Our second class lever would be, pushing up onto the balls of your feet. And that's because, if you think about this, the fulcrum is at the pivot point, so that's where you lift up, right? That's on the ball of your foot. The effort is your calf muscle over here, and the load, so to speak, is through the heel. It's a lot of things. The load is not as simple as just saying one particular point, like on, using a lever to lift a box or something. But we say that the load is in the center there. So just writing this down. So the fulcrum is the ball of the foot, the effort is your calf muscle, and and the load we think of as the heel, so which is between the two. Okay, and the third class lever is your bicep curl. Okay, here you've got, and then this looks confusing in the picture, but I'll tell you why. So say you're lifting, whatever your hand weight, your dumbbell, you're doing your weights here, and you're doing your bicep curl. You are working your bicep when you're doing that. So if you think about it, you look at your arm right now, you think, okay, well, there's my hand. Then I've got the fulcrum in the middle. You might think, here's my weight, here's my fulcrum, and it's my bicep, which is right here doing the work. So that would be a first class lever. It is a bit more confusing in the body because if you look down, the bicep connects in between the joint at the elbow and the hand. So even though it looks like it's a first class lever because the bicep's up here, in fact it is a third class lever because it's joining right here. So distinguishing between classes of levers, where the load is, where the effort is, and where the fulcrum is. And I wouldn't expect you to be able to look at just a general random picture of the body and decide what was what, but certainly these are examples, okay? And we do an example later on, with some calculations related to the body. Big thing is we don't do too many because they're difficult. One reason that this is very difficult is that, and we try to simplify it a bit. But as I was saying with the calf muscle, we say that the load is the heel, but it's your whole mass you're lifting. It's not as easy to say. It's just your heel that you're lifting as far as the force of gravity, or even on the arm here. It's the weight, but it's also the weight of your arm. There's a lot going on, and so we don't get too much. We don't want to try to overcomplicate them, but it is good just to be aware of them. Okay, here's another type of, and in fact it is a lever, and that's because you have a fulcrum, and you've got an effort, and you've got a load. Okay, so the way a pulley works, it's a simple machine in which there's a wheel with a grooved rim. Right, here's our wheel with our grooved rim, and carries a rope attached to a load. And the way that, so the load is always what you're lifting, effort's obviously what you're putting in. I like this picture of it because this sort of shows how you get mechanical advantage, right? If you're lifting a big heavy weight, it's heavy and it's hard to do, right? Well, you stick it over a pulley and that makes it a bit easier, but the more pulleys you add to your system, the dude here can do it just with one hand, right? It gets easier and easier. So adding pulleys increases mechanical advantage because now this is getting easier to do, even though you're lifting the same weight. And there's a little lab with pulleys that if you have to have some patience in setting the pulleys up, and it takes a little bit of a will and desire to do it, but it's a good lab showing mechanical advantage through pulleys. Okay, just another one is the wheel and axle. And in the wheel and axle, the idea is that you're spinning. Here's my wheel, here's my axle, right? and you spin it, and it makes it easier than lifting the load than it would otherwise. Okay. Gears. We know this is true that if you if you ride at a high gear, okay, you have to put a huge amount of force in, but you go further. Or you could ride at low gear, and you can put a little bit of force in, but don't go as far, right? And that you can tell almost by looking at it why that's true. Is the amount that you turn your wheel, your pedal, right, has a bigger effect on the rotation of the bicycle wheel. Okay, the second class, so the first class of inclined plane, first class of machine are all pulleys, levers, and that's what we just looked at. The second class is anything with an inclined plane, and the most basic of which is actually a ramp. So here, you gain some mechanical advantage because it's easier to push this up here, up the wheelbarrow, up the ramp, than it would be to try to lift it up and place it, right? So an inclined plane or a ramp gives you mechanical advantage because you have to put less force in. I mean, it's true, you have to go a further distance, but it's still easier to do because you don't have to put as much force in. You might be hearing me drink my coffee, actually. Sorry about that. Okay, next one. So different things that fit in the idea of an inclined plane family. You know, a wedge, really, it's just two inclined planes. If you tried to, you could hit as hard as you wanted on that piece of wood. If it wasn't an inclined plane, you wouldn't be able to use enough force to crack it, right? And finally, the screw, and that is an inclined plane as well. Okay, because again, if you want to just push through, maybe with a hammer you could, but if you wanted to, you could use less force and just use a little screwdriver, right? By working the inclined plane. So those are some basic, what we call simple machines. And a compound machine, again, is if you put you put more than one of those together, have two machines put into one. But yep, that's it for the simple machines note, and that's it for today.